Maybe I need to stop saying that. Okay, yesterday we were in a hurry because we did that 12-1 test. Did you make sure I've seen your worksheet and your study guide? Because I'm typing in grades for that this afternoon. Did you make sure I saw your worksheet and your study guide? Everyone did. If you didn't come finish that 12-1 test, I like 3 come finish 0 period, which was awesome. If you didn't, you need to come finish ASAP before I type in the 0, which you don't want because most of the people have the 100. So come on. Today you're going to get a maze. It's going to be worth 10 points. It's really fast. If you want to show it to me before you leave, you can. It's okay if you don't. And then I want to talk about, sadly, we're not done. So we just learned right triangle trig. And you learned that in geometry. We need to do a little more than that in order for this to be Algebra 2 with trig. So we're still going to do math, but the good news is since life's so crazy and so many people are out and all that jazz and seniors and life, the next test is actually going to be posted on Google Classroom. So I need to get you my code because you don't have it. Yes, dear. Here?
I think it was 51.
51. Okay, so there is going to be a test literally on Google Classroom, which means Anne-Marie can cheat. Now, Anne-Marie is not normally a cheater, and I do not condone cheating, but if I'm posting a test on Google Classroom, good gravy, why is Anne-Marie not getting a perfect score? I'm telling her, Anne-Marie, the next test is going to be on Google Classroom. Anne-Marie can literally bring me a handwritten version of her answers. She can print it off and write on it. She can take a picture, upload it. As long as Anne-Marie sends me her answers and her answers are correct, she's going to get the 100. So literally the only way I think Anne-Marie's not going to get 100 is if she just chooses not to do it. Anyway, there's going to be a test on Google Classroom, and the deadline's going to be next Friday. In fact, I might change it to next Saturday to help those people help life out a little bit. But I really would like it to be as soon as you could, so we can go ahead and lock down your grade to determine exemption and all that jazz. But I digress. Okay, so one last period was like, Miss Compton, I told them that you could Google math. And they said, Miss Compton, you can't Google math. I always get the wrong answer. I don't know what you're Googling or how you're Googling it. Clearly, you're not looking at the right website. That's my favorite math website. It's Wolfram Alpha. It does my college level math. So surely it can do what you need. Last night, I didn't have a calculator with me, and I needed to know, like, a log problem with a weird base. I asked Wolfram Alpha, it told me the answer. What's good about it is it can also show you the steps. But you know, when you copy math, life goes wrong. So make sure you do actually understand what on earth it says, if that's what you're choosing to do. Okay, since we're not going to lie and say we're not being lazy, because we are. Number 10, we're actually supposed to do it a different way. We're supposed to know, like, the square root of 25 is 5. 5 to the 3 is 125. Since there's a negative exponent, it's really 1 over 125. But let's be honest. So what Jax was supposed to do, he was supposed to say it's 1 over 25 to the 3 halves. He was supposed to say, okay, really that's 1 over square root of 25 raised to the third. So really that's 1 over 5 to the third, which is 1 over 125. But let's be honest, Jax did not do that because he's forgotten how to / his brain is tired. So what is Jax going to do instead if he were to see one like this on the semester exam? He's literally going to put it in his calculator. What could go wrong, though, if he's putting this in his calculator? He could not put it in parentheses. That would be a major problem. Or he could just not type in what he sees. So 25 raised to the parentheses negative 3 halves. I get 0.8, and let's see, 1 divided by 125 is 0.8. If you were wanting your calculator to put it back in fractions anyway, our calculator can. Our calculator's smart. If you tell your calculator math frac, it would turn your answer back into a fraction anyway. So Jax was concerned because all the options were fractions. No big deal. Your calculator can take your decimal and turn it into a fraction. God bless whoever invented the calculator. They were genius. Okay, so on the second problem, what should you get on number 11? The negative 32 raised to the 3/5. I got Negative 8. Okay, why does Jax need to be careful on number 11? What else could go wrong on number 11? The parentheses. So he's got to make sure he puts that negative 32 in parentheses. It would all work out for this one because it's odd exponents, so we did want a negative answer. But if your calculator doesn't know what's on your paper, so if you put negative 32 squared and then parentheses negative 32 squared, you end up getting a positive and a different negative version. So you've got to make sure you're putting it exactly like you see it on your paper. We can't put number 12 completely in our calculator because of that variable, but we can put, so we could break it apart and say 125 raised to the 2/3, x to the 6 raised to the 2/3. I can put this first part in my calculator. So 125 raised to the 2/3, I can get 25. So I know I've got 25, and now I've just got to deal with the x to the 6 raised to the 2/3. When we're raising powers, what do we do to our exponents? We don't add. When we multiply, we add, yes. When we're raising, like x to the 3rd raised to the 4th, you end up multiplying. So we need to multiply here. So I'm going to do 6 times 2/3. I already know that, but again, my brain getting a little slower and slower. So 6 times alpha y equals 2/3, and I get 4. So it's 25x to the 4. Now, did I know 6 times 2/3 was 4? Yes, but again, I can always ask my calculator just in case. I did those fast. Or any questions to those who are alive about that? Okay, then as for today, so life stinks in that area. It's going to take a day or two for us to somehow connect what we're going to do today to what we just did. So we're wanting to get to something called a unit circle, because that's where like the lifeblood of trig lives. But to get to a unit circle, you have to be able to read stuff on a circle, or to read angles, I should say. And so we've got to talk about how to read angles before we apply sine, cosine, tangent, and all our trig values to these angles. Okay, so I know this is really bad that I'm going to say this, but I've forgotten it was called an initial side and a terminal side. So you do not need to know, I mean, those vocab terms, great vocab terms, but you don't have to know them to be successful in life. What you do need to know about when we have an angle. So, normally in life we read things clockwise. What's weird about math is that when we're doing angle measure, we go counterclockwise. So that's why, so when Jax reads this, he's reading this way. He's going around the clock the opposite way. Okay, well, you don't really need to know the vocab terms. You do need to know, so we've got this coordinate plane, and we're trying to put angles on this coordinate plane. You're supposed to know that this is 0, and then if we were to go all the way around in this coordinate plane, if we were to start here, and our angle went all the way around, we would make a circle, which means we went how many degrees total? Yeah, we went 360. So if there are 4 dashes, then 360 divided by 4 is 90. So this is a 0, this is 90, this is 180, this is 270, and then, when you get back to the beginning, you're at 360 or 0. They're the same spot. It's kind of like 3 o'clock is the 3 o'clock spot. Like if you, at 0 degrees, at 360 degrees, we're actually at the same spot. You do need to know this one's 90, this one's 180, this one's 270. It just makes your life so much easier. So they ask us at the bottom to sketch some angles, and it's actually going to be really fast. We're going to do number 1. So I know this is 90, I know this is 180, and I'm telling you that's 270, and that's also 360. You can put the numbers if you want. But I'm smart enough to realize, hey, 100 is somewhere between 90 and 180. So 100 is, let's say, in here. It's pretty close to 90. So my angle will look like this. this initial side, again, vocab term that you don't have to memorize. This initial side is always this line. Okay, so if we're going to, let's go to number 3. 90, 180, 270, 0, and 360. 225, let's see, that's somewhere between 180 and 270. It's a little bit closer to, I guess it's about the middle, so I'll put it right in here. I'm just making a good educated guess today. I'm not trying to be exact sciencey with it. And then there's one that says 210. Well, if this is 0, 90, 360, 180, 270, and you don't have to put the numbers every time. I'm just the teacher trying to explain things. 210 is a little bit closer to 180 than 225 was. So what we're saying when we say this angle is here, we're saying we started here and our angle opened up to there. If you want to draw these kind of pictures for you, you can. And again, you and I are reading counterclockwise. Counterclockwise. So what happens when they're negative is that we've gone the opposite direction. We're, instead of going counterclockwise, we're going clockwise. So for number 2 and number 6, for the negative, instead of going counterclockwise because they're negative, we're going to go opposite direction. So let's see. This was 0 and 360. This is 270. This was 90. This was 180. If I'm going negative 45 degrees, that means I'm going down 45 degrees. I'm probably somewhere in here. Because again, we're saying we went negative 45 degrees. We went back 45 degrees. So back 75 degrees, you're like, okay, that's somewhere in here. Now, if you don't like that and you're like, what the crap, I don't like that at all. Anytime you see negative ones, just do 360 minus that number. 360 minus 275 minus 75. Miss Compton can read today. Is 285. Well, we just talked about this is 90, 180, 270, 360. You're like, yeah, that's about where I would have drawn 285 anyway. Same thing with negative 45. If you did 360 minus 45, you would get 315. Well, that's probably where I would have put 315 anyway, because it's closer to 360 than 270 and somewhere in here. So if you're having trouble with the negatives, do 360 minus, or 360 plus that negative number, 360 minus your number. Make it not negative. Okay, what happened on number 4 and number 7? Why are they so big? It says 450 and 540. What happened? They did. So they went the full circle around. They went 360 and then they went some more. So if we do 450 minus 360, we will get 90. So Karen's right. They started at our initial side. They started here. They went, and you don't have to draw this if you don't want to unless it helps you think. They went all the way around 360 degrees. And then they went some more. They went 90 degrees more. So they ended up stopping at 90. So 450 is the same angle, or it's drawn in the same position as 90. If you did military time, 1,300 hours and 1 hour are on the same spot on the clock. In the same way, these are the same spot on this coordinate plane. Okay, so 540 minus 360 is, it's 180. Is it? Okay, thank you. Okay, so literally it's going to be a flat line, which seems dumb, but you're like, yeah, the clock sometimes looks like that. I can see that. So literally what they did is they went around 360 degrees, and then they went around 180 more, and that's how they ended up at this spot. Okay, so flip to the back. The back is yours. It's an easy maze to follow around just to practice this. Make sure you can read stuff. So on the first one, since they're going back so many degrees, you know it's negative 135, so you go down to here. And if you follow the maze around, you'll end up ending up at the end. That is one of the things you need to do today. Saturday, there is another thing you need to do as well. So the maze is not due today, but could you knock it out quickly? Yeah, you can. What we're going to